Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. And in this video, we're working on that Unit 2 and then lesson number 11 now. Still working with the intro to slope and talking about and keeping in our heads those ideas about those similar triangles and how they work with slope. And so in the first part, for the warm-up, it says find each of the following and explain your reasoning. So find the length of BE and then the coordinates of E, the point. So in the first part, we're going to say, for number 1, our triangles ABE and ACD are similar. That means when we write the ratios of those side lengths, so notice when I say AC, I'm talking about that long length AC, the bottom length AC, and the bottom length AB. So that's how I have to make sure I have those those corresponding sides. So I can say the ratio of those corresponding sides is equal to the ratio of the other corresponding sides. So I can say BE and CD. I can write some of those side lengths, so I write 4 over 2 is equal to 5 over BE. And so I have to say, well, what number times 2 equals 5? And I can say, well, that length BE, meaning this short length here, is going to be 2.5. And so now we can take that length, knowing the length of BE, we can add 2 plus 2.5 to get our y value. Remember that you have an ordered pair, x and y, so we have to say the coordinates for point E are going to be 2, 4.5. So that's that point right there. Alright, in the next part, it says line J is shown in the coordinate plane. What are the coordinates of B and D? So again, it has that line going through the origin, 0, 0. We're talking about that point B and that point D. Again, when it says coordinates, we're just talking about an ordered pair, x and y. So that means for that point B, again, find your x value first. So we're going to say 4, find your y value 3. So we say 4, 3 for B, and then since it's on the same line, notice how it has that same ratio. So we're going to say that that point D is going to be 8, 6. For number 2, it says, is the point 20, 15 on the line J? Explain how you know. So we're going to say, even though we do not see the point, meaning notice how our x value doesn't go up to 20, we know that 15 over 20, meaning y over x, is equal to 3 over 4. So we can say the slopes are the same, and that would mean that would be on that same line of J. If you wanted to, you could have also graphed it out further and kept going to see if it's actually on that line. But as long as you're following that staircase like we talked about before, you'll be good. For number 3, it says, is the point 175 on the line J? Explain how you know. So we could say we know that 75 over 100 is equal to 3 over 4. Again, notice how those equivalent ratios are the same. So we're going to say those triangles are similar. So as long as it's on that same line J, meaning the slope is 3 over 4, we know we're good. Again, change in y over change in x. So that's why we have 3 up and 4 to the right. For number 4, it says, is the point 90 and 68 on the line J? How do you know? So for this one, we would say, actually, since 68 over 90 is not equal to 3 over 4, the point 90, 68 is not on that line J. So if that ratio between those two values is not the same as the slope, then we know that it's not going to be on that same line J. And then for number 5, it says, suppose you know the x and y coordinates of a point. So any point that we have on our graph. Try to write a rule that would allow you to test whether the point is on that line J. So we're trying to figure out, well, we did a couple examples where now we're trying to say, okay, how can we come up with a rule or an equation that would work out for any point? And so we could say the quotient of x and y values has to be 0.5. So as long as we have that rule, we should be good. Again, be careful. Notice how that point A is at the point 0, 0. Since we can't have an undefined value, we just say that point 0, 0 is included on that line. For 11.3, it gives you 2 pictures. It says here's our 2 diagrams. So those are 2 different equations or 2 different lines on the coordinate plane. For number 1, it says complete each diagram so that all vertical and horizontal segments have expressions for their lengths. For number 2, it says use what you know about similar triangles to find an equation for the quotient of the vertical and horizontal side lengths of triangle DFE in each diagram. So make sure you're talking about, again, when it says expressions, that kind of looks like you have to have an X and a Y. You have to write, quantities and variables. And so for number 1 on the first graph, it should look like this. I can say on the graph of line K, segment DF in green, I can label it as just X. For my segment EF in pink, I can have my vertical segment. That's going to be Y minus 1. Still on number 1, but on the second graph now, I can say on the graph of line L, segment DF is going to be X minus 2. And segment EF can be labeled as Y minus 4. So that's my vertical segment. So now for number 2, we were saying to use what we know about similar triangles to find the equation. So we're going to kind of combine those two ideas. So we're going to, for line K, I can write the equation that goes for any point xy. I can write it as a slope, so I can say y minus 1 over x, so change in y over change in x is going to be equal to 3 over 4. So notice how I go from an expression to an equation because now I have an equal sign. For the other diagram, I can say for line L, equation is satisfied by the point xy. I can say y minus 4 over x minus 2 is equal to 3 over 4. So notice how those triangles in both of those shapes, notice how they're similar. We're writing equivalent ratios for that long side and that short side. And I could say I know these equations are true because the slope of a line is always the same no matter which slope triangle is used to calculate it. So as long as I'm using that information they have from the given triangles, I can write that ratio for ourselves. So be sure to pause the video and record what you need, ask questions as they come up, make sure this page gets into your binder. For the exit ticket, it looks something like this. It says, for number 1, explain why the slope of line A is 2 over 6. For number 2, it says label the horizontal and vertical sides of a triangle with expressions representing their length. And then for number 3, it says explain why y minus 7 over x minus 5 is equal to 2 over 6. So kind of just like that last problem we did. And I want to make sure you're remembering, again, slope is equal to the change in y divided by the change in x. It's always going to be that ratio. So it's you change your x values, talking about left and right, and it's going to be your change in your y values moving up and down. So for that first one, we can say the points 5, 7 and 11, 9 again are pointed out on the graph, and they're on that line A. So using these to find the slope gives us a value of 2 over 6, which is the same as 1 over 3. So again, make sure you can have the change in your y values divided by a change in your x values. For number 2, we want to label those sides with the expressions. So we're going to say that we can label the vertical side in pink with y minus 7, and we can label that horizontal side with a length of x minus 5. So again, notice how we're taking that amount that we have. We know the point 7, so we can take this point xy, we take y minus 7 because that's our vertical distance, and we take x minus 5 because that's our horizontal distance. And then for number 3, kind of putting all these ideas together, we can say the triangle in the picture is a slope triangle, so that means the quotient of its vertical and horizontal sides, the x and y, has to be 2 over 6. This means that the ratio, we can say, again, this is a fraction, y minus 7 divided by x minus 5 is equal to 2 over 6 is true for any point x comma y on this line. So again, we have any of those ordered pairs that will be on that line, we can find them by using these values. So we should be able to calculate, and it should make a ratio that's 2 over 6. If it's not equal to 2 over 6, then we know it doesn't fall on that line. Be sure to Ask questions if you need to. Make sure your name is on it and turn it in. And as always, super slam that subscribe button.